This is Michael from Blue Sky Bio. I'd like to welcome everybody who's joining us. We'll get started in just a minute. We'll let people finish joining the session and logging in. Okay, this is Michael from Blue Sky Bio. I'd like to thank everybody who's joining us for the present live video training session. If you have any questions during the presentation, please feel free to enter them into the chat box and I'll address them as we go along. Please also make sure to enter your details into the webinar attendance form in order to make sure that you get sent to the CE credits. The webinar attendance form, there are links to it under the viewing video windows, and there was a link to it sent out earlier today with the viewing link details. I like starting these sessions by giving a little bit of background and perspective regarding guided surgery. A few years ago, in order to get started with guided surgery, you needed to start by buying guided surgical software. You needed to then buy a guided surgical kit. You needed to often pay for conversions of the DICOM files, and then, of course, pay for the surgical guide. We've gotten to the point today where you could use free software. No conversions are necessary. You can load the DICOMs directly into the software. There's a single direct cut drilling protocol, which also removes the need to buy a full guided surgical kit. And of course, the process of ordering a surgical guide and the cost involved with it have been reduced. And that really brings us to the topic of today's presentation. We're going to be discussing two different techniques for surgical guides. Both of them are great options. One of them is ordering a surgical guide from a dental lab, which is what we refer to as the in-house option. And the second option, which refers to as the in-clinic option, which is based on printing a model with posts coming out of it and then making a surgical guide via that option as well. So we're going to be discussing both of these options, and we're also going to be discussing how to make the surgical guides using Blue Sky Bio parts and not using Blue Sky Bio parts as well. Both options can be used, both techniques can be done for all guided surgical kits and all implant systems. Okay, we're going to start by discussing the technique of fabricating a surgical guide based on the model with posts. Before we do that, we have to ask the questions: why do we need two different guide fabrication techniques? Why do we need both the technique of digitally designing the surgical guide and also the option of printing the model with posts and then doing a suck down or vacuum press in order to fabricate the surgical guide? And the reason being is if you're doing a digitally designed surgical guide, then you need access to a 3D printer that can print biograde material. If you're doing the option with the model with posts and then doing a thermoplaster suck down, you're able to use a 3D printer that could print at a high resolution, but doesn't necessarily allow you to print with a biograde material. The reason being that the model with posts, which is coming out of the printer and being printed, is not going to be going into the patient's mouth, and therefore the requirements for the printer are lower. And because of that, the printers are much more readily available and could be bought for a much cheaper price. So therefore, the model with post technique, we often refer to as the in-clinic technique. A clinician, if they wanted, could get their own 3D printer, or they could use more of a local printing center, while the digitally designed surgical templates, which is used with a printer that could print biograde material, we often refer to as the in-lab solution, as it's often a solution used by a lab that has a higher level, more industrial biograde printer. Okay, so with that background, we're going to start discussing how to set up the model with posts in order to fabricate a surgical guide. Now, in both techniques, the first step really is importing an optical scan of an STL model, either an intraoral scan or an optical scan of an STL model. The reason that this is done is really twofold. One is the accuracy of an optical scan is higher than the accuracy of a CT scan, and when we're fabricating a surgical guide, we obviously want to have it as accurate as possible. So we want to fabricate the guide, we want it based off of a higher resolution scan. And the second reason being, when you're dealing with a CT scan, you have the question of the density threshold. Okay, you should probably be familiar with the density slider that we see in the bottom left of the 3D view, which changes the density threshold, and also changes the shape of the anatomy of the object that we're dealing with. Because the shape of the object can change, it can also create a change with the surgical guide, which is not an ideal situation. The optical scans or the intraoral scans create a surface which is either black or white. It doesn't have the density threshold, it doesn't have the grayscale settings of a CT scan. Rather, the object is much more clearly defined, either there or it's not there. So it eliminates the question by using an optical scan or intraoral scan, eliminates the question of what exactly is the correct density threshold. Therefore, because of that, as I mentioned, we're going to be importing an STL model into the software. Now, the process of importing an STL model, if it's done correctly, is generally a quite quick and very accurate process, and therefore we're going to spend just a few minutes to discuss the importation process. The model should be imported after the treatment plan is completed. It's going to be merged with the data from the CT scan, and then we're going to use that in order to create our surgical template or in order to create the model with the post coming out of it. When we're getting ready to import the STL model, one of the things that we want to do is we want to remove any of the extra anatomy or extra noise or extra scatter. The way that this could be done is in the surfaces panel. You're able to use the isolate function, click what you want to keep, and as you can see, the software has just removed anything that's not connected to the surface that we clicked on. So that got rid of some of the noise, some of the scatter, extra anatomy, and we have a much more clearly defined CT scan that we could use for the merge. Another good idea is to raise the density threshold. We're going to be doing the merge based on points on the teeth. The teeth obviously are more dense, and if we raise the threshold, it clears up the scan a bit, and it makes the teeth easier to see and easier to identify. We could turn off the abutments, the implants, and the software guide tubes. That's not necessary for now, so we've hid them from the treatment plan. So this is kind of the prep that you want, the situation you want to be in before importing the model. You want a clear CT scan where you can see the teeth, and you want to remove any data or information that's not necessary. Once you're in this position, you go to File, Import STL Model. You can navigate to the location on your computer where the STL model exists. You select it, and the software is going to bring it in. You could see what happened here is the software kind of tosses the STL model into the treatment plan, and now we're going to align it. The model manipulation panel has automatically opened when you import the STL model, and the preferred and recommended way of doing the alignment is by using the points option. There's other functionality built in to handle all sorts of other types of merges. You could also adjust the model position manually, which we're going to discuss. There's an auto option that will do a very, very rough alignment. There's a center option where we'll put it into the center. But what I recommend, go to the points, select the points option, and then click Align. What the software is going to do for us is open up in side-by-side windows, one window that contains the CT scan and another window that contains the optical scan or the intraoral scan. We're going to identify points that we can see clearly on both scans. We're going to mark those points, and the software will do the merge based on those points. The mouse functionality that's generally used in Blue Sky Plan can be used here as well to rotate, zoom in, zoom out, or do any of the standard features. When you want to start marking points, then you hold down the Shift key, and you can see the arrow turns into crosshairs, and you're able to start identifying visible locations and marking them in the software. Now, the order doesn't matter. It doesn't matter if you go 1, 1, 1, 1 back and forth between the different scans, or if you do all of them in one scan and then do all of them in the other scan. We recommend at least 5 points. The more points, the better, and the more accurately placed, the better. And they should be distributed. They should be distributed throughout the scan, mesial, distal, buccal, lingual. So we're going to go ahead and now mark the points on the imported STL file as well. Going to do this a bit quickly. Okay, once we have our points marked in both of them, then we could go ahead and press the OK button. Now we could see what happened here. The software did the merge. Okay, we've merged the STL of the model with the CT of the patient. Now the question obviously is, how do we check the accuracy of the merge? The way to check the accuracy of the merge is, first of all, to turn on the model outline that we have in the model manipulation panel. And what we see happened is in our 2D views, we now see an outline of the model. The way to check if the merge was done well is to look in the different views in the areas where there are teeth. Okay, in the areas where there aren't teeth, there will be an understandable difference between the two scans, as the STL scan will contain the soft tissue and the CT scan may not. So you want to look in the areas where there are teeth, for example, in the cross-sections view, and you can start going around the arch in the cross-sections view, and you could see how the outline of the model hugs tightly around the teeth. Okay, this is an indication of an accurate merge. We could check in the axial view as well. As we get closer to the occlusion, we want to again see that the model is hugging tightly the teeth. Okay, and we see that this is indeed the case, and we could see this in the tangential view in the top right view as well. So that is the best way to check if the merge is done properly, if the merge is done accurately. Now, if it's not, and you want to redo it, then once again, I'd recommend going back to points, hitting the line button, distribute your points better, add more points, and be more careful with how they're being placed, and that should deal with the situation. Okay, if still after that's done, you still want to modify the placement, then you could use the Adjust Model Position Manually button, and you could see that a widget similar to the implant widget appears on the model, and you could use any of the circles to rotate the model in any direction. You're also able to grab the arrows and to use that to move the model in any direction. We've also built into here some more advanced functionality. If you wanted to rotate, but you don't want to rotate around the middle, because for example, let's say one side of the patient is aligned well and the other side is not. So essentially you want to change your position or your axis of rotation. So you could use the little arrows that you have here to realign the widget, and then you could use the circles to rotate. It will rotate based on an axis that's now in a new location. Okay. Another way to adjust the positioning, which is something that we've come out with very recently, because we had the request that people just want to move the model literally pixel by pixel. They just want to fine tune and be able to nudge it. So when you go to adjust model position manually, then click on the circle that appears, which represents the axis of rotation, you could then use the arrows on your keyboard. And every time you tap an arrow, you could see how fine the movement is, almost on the pixel by pixel level, and you could use that to really nudge the model into the perfect alignment. But to summarize, regarding the alignment process, the first thing you want to do is you want to make sure you have as the best visualization possible, remove any unnecessary anatomy, raise the density threshold. You want to be able to see the teeth as clearly as possible, and then you go ahead and do your merge. I recommend using the points functionality with the line button. Distribute those markers, put in markers, put them in accurately, and you should have a very fine model, importation of a model. Okay, so now we're at the time where we got the model imported. We have our treatment plan planned. Let's turn our implants back on here. And during this session, we're not going to be discussing, the basic functionality of the software, how to place implants. We're not going to be discussing that. We're assuming that at this point you know how to do that, and if not, there are other webinars or other tutorials on how to do that. We're not going to be discussing that now. So we have the model imported. We have our treatment plan planned. Now the question is how to convert this into a model with posts. And the answer is split into two. One is if you're using Blue Sky Bio parts, and the other one is if you're not using Blue Sky Bio parts. We obviously recommend using Blue Sky Bio implants and Blue Sky Bio parts, but the system, both the software and the guide fabrication functionality could accommodate all implant systems and all guided surgical kits. So let's discuss if you are using Blue Sky Bio parts first, because that is a little bit more simple and we'll explain the process. And then we could go ahead and discuss how to change the settings if you're not using Blue Sky Bio parts. If you are using the Blue Sky Bio parts, then you press a button. The button is in the implants panel, and it says direct cut settings for printed model. You press the button, and let's check what has now happened to our case. First of all, we could turn off the CT scan. And let's see what we now have here. That's it, we're done. We've transitioned, we've converted the treatment plan planned into a model with posts ready for export. You could see now that the posts are sticking up out of the model. The brown software guide tubes are the shelf that's going to be holding the metal cylinder. All of this is going to be sent to be printed. And when you get it back, you're going to be putting the metal cylinder, you're going to slide the metal cylinder, it's going to fit, you're going to slide it directly onto the shelf, do a thermoplaster or suck down, and that's going to be your surgical guide. Let's just jump quickly to the website to take a look at some of the pictures we have here that will demonstrate that. Okay, we have an example case study that's here. Let me zoom in a little bit. The printed model with posts that you see is how it's going to come out of the 3D printer. You got the model, you got the post, and you got the shelf. You could then take the metal cylinder, slide it onto the posts. You could do a thermoplast to pick up the metal cylinder, and it obviously will pick up the shape of the model as well. And that becomes a surgical guide. Okay, it's as simple as that. So jumping back to the software, what we did again, the treatment plan was done. We imported the model. We pressed the button, direct cut settings for printed model. The changes were made. It's ready to be printed. And that's that when you're using Blue Sky Bio parts. Now, we also have a parts panel. The parts panel automatically populates with the relevant parts that you need for the case based on the implants that were treatment planned. Okay, so it shows you the implant, so it shows you which metal cylinder, it shows you the drill, and it shows you if you want to use the printed drill stops, which printed drill stop you're going to be using. You could check or uncheck the boxes. You could add the parts to your shopping cart. The checkout is quick and easy, and the software takes care of all the settings, so all of which telling you which parts you need, and that's covered. Now, the export process is you go to File, Export Data. And it brings up our export panel. When you export, you want to export three things. You want to export the model, which is your STL surface in the top middle box. You want to export the abutments, which has been converted into your post, and you want to export the drill guide, which creates the shelf. Okay, you could check and uncheck all the check boxes in the column by clicking on the top of the column, but you want to, again, export three things: the model, the abutment, and the drill guide. You press the export button, you choose where you want to save it on your computer. It will save it as a single STL file with everything together, and that is what you're going to have printed. Now, if you want to do the process and you want to use other parts, you want to create the surgical guide to accommodate another guided surgical solution. So the first thing you need to know is you need to know which metal cylinders you're going to be using. The metal cylinder that you're going to be using is a function of what's going to be going inside of it. If you're going to be using a key or a handle that's going into the surgical guide, then you need to know what the outside diameter of the metal cylinder of the metal handles are. Or you need to know the inner diameter of the metal cylinders that are used for that particular system. Just to jump back to the website, we have a tube store that has around 50 or 60 different metal cylinders. They're all listed here. And with this variety, we could accommodate any guided surgical kit that's out there. But the first question really is which metal cylinder is going to be used? What's the inner diameter of the metal cylinder? So let's go back to the software. Even if you're doing this technique for not Blue Sky Bio parts, the first thing you want to do is press direct cut settings for printed model anyway, because that's going to set a lot of the defaults. We can now go ahead and make the changes. So what changes do we need to make? We need to update the following items. Let's pick a metal cylinder. Let's say we're making a surgical guide for a metal cylinder that has an internal diameter of 5.02 millimeters. That's a popular metal cylinder. The first thing we need to update is the diameter of the abutment. Okay, if the metal cylinder is 5.02 millimeters, so you need to make the abutment, which is the post, around 1/10 of a millimeter smaller so that the metal cylinder could be slid onto that. So we would make this 4.92 millimeters. The next thing we want to do is we want to update the software guide tube settings. The software guide tube settings, those are in this situation, it's the shelf. It's the shelf that's going to hold the metal cylinder. So if our post or abutment is set to 4.92, we want to make the internal diameter of the software guide tube slightly smaller than that to make sure it's flush up against the post. And then we want to make sure that the outer diameter is around 2 millimeters larger than the internal diameter. And that's what makes our shelf to hold the metal cylinder. Now these settings you could then apply to all three, or however many number of implants that you have. You could apply it to all of them, and that would be that. So to summarize, the difference between if you're using Blue Sky Bio parts and not Blue Sky Bio parts is if you're not using the Blue Sky Bio parts, then you want to update the abutment diameter, which is the diameter of the post. You want to make it around a 1/10 of a millimeter less than the inside of the metal cylinder. And then you want to update the inner and outer software guide tubes. The inner should be slightly smaller than the abutments, that they're flush up against each other. And the outer diameter should be 2 millimeters larger than that. That's the difference between the Blue Sky Bio parts and the non-Blue Sky Bio parts. It's really, either way, it's a pretty simple and straightforward solution. To respond to some of the questions that have come into Blue Sky Plan, you're able to import STL files. So whether it's an intraoral or an optical scan, it needs to be in STL format. We can't handle other non-STL imports of models or intraoral scans. I think Sirona has a service that they might do the conversion for you, or there might be other services. I know there was one for the CDT file type. I don't know with their newer system if there's a conversion for that as well, or you might be able to ask them to convert it for a fee. But you need to get into STL format in order to import it into Blue Sky Plan. A bit later, we're going to take a look where you could possibly get the model of the post printed. We'll go back to the website after we discuss the digital design technique as well. We'll discuss where you could have these items printed, what the costs are, and the details regarding that. Before we move on to the digitally designed technique, let's take a look at this situation here, where you could see that it is an intraoral scan, and if you sent this to be printed, then the printer might say it can't be printed like this. In order to deal with such a situation, we've built into the software the ability to close the bottom to add a base. Okay, that will bring us back to our model manipulation panel. This is where before we did the alignment, and the reason that we built into here the closed model functionality in this panel is because we thought that if you're importing an intraoral, at the time of importation, it would be convenient to be able to close it. And closing it is very simple. You could decide the thickness of the base, and you could press the close model button. What you could take into consideration is it takes the lowest point of material, uses that as your kind of ground zero, and then if you add any thickness of a base, it's going to add it onto that lowest point. So generally, you really don't need a thick base, so we'll just close the bottom up, whatever it is. Another good idea is if you want to keep the printing to a minimum, then in the surfaces panel, you could select the relevant surface. You could use the cut technique, and here you could just lasso off any material that you want to remove. Okay, the software is processing in the bottom left. We could see that, and you could see how it just cut out whatever we lassoed. So you could go ahead and you could cut out all the extra pieces of material. You could then add a base to it and then send that off to the printer. Okay, so that that summarizes our model with posts technique. Let's just review a couple of let's just review the process flow. The process flow is you have the CT scan with the treatment plan completed. You get rid of any extra anatomy or interference. You import the model by going to the points technique and align. You distribute the points mesial, distal, buccal, lingual. The more points, the better. The more accurate, the better. And then you import the model. Once the model is imported and the treatment plan is complete, to transfer it to a model with posts ready for printing, if you're using the Blue Sky Bio parts, you press direct cut settings for printed model and you're done. You could check the parts in the parts panel and you could order whatever you need. If you're not using Blue Sky Bio parts, you still press the button because that takes care of some of the height and offset settings. But then you go ahead and make 3 changes. The first change is the abutment. You want to make the abutment to be slightly thinner, around a 1/10 of a millimeter thinner than the inside of the metal cylinder. And then you want to change the software guide tube inner diameter to be flush up against the post, which is your abutment. And you want to make the outer diameter 2 millimeters larger than that to create the shelf. You go to File, Export Data. You export it for printing. And when you get it back, you put the metal cylinder onto the post. You do your thermoplasty or suck down, and that's your surgical guide. Okay, again, that's the technique that we usually call in office or in clinic. It doesn't require printing with a biograde material. If you're interested, printers that could do this generally run under $3,000. So if you're going to be doing a lot of surgical guides and you want to do it in-house, then you could really do the entire process in-house. So that's the model. That's our model with posts technique. Okay, moving on to our digitally designed surgical guides. The digitally designed surgical guides, as we mentioned, requires printing with a biograde material. It's generally referred to as an in-lab solution. And everything is built into the software that you could do the full digital design of the surgical guide in the software with no other software necessary. We've recently added in, which we're not going to get into now because it would take too long and it's more advanced functionality, but just so you know that it exists, we've added in some advanced jaw segmentation and jaw definition functionality, which helps with bone supported surgical templates. Okay, if you're doing a bone supported surgical template and the bone is soft or has holes in it, until we've integrated it, the only real way to make a surgical guide would be to have somebody that's trained in CAD/CAM, could fill the holes, could create a solid surface, and then to use that to make the surgical guide. We've built that functionality now into Blue Sky Plan. It could be done by anybody that goes, watches the video and then practices a little bit. And that's really brand new functionality. It's really brand new and really advanced new functionality that's in the software. Okay. Okay. The first thing we do is once we have our treatment plan completed, and we're going to be discussing the process flow with Blue Sky Bio parts first. Once we have the treatment plan completed, we import the model, same technique, and then we press the button, direct cut settings for printed guide. We could see what happened here is that our software guide tubes have moved. The software guide tubes are going to be, or what they represent is the hole in the surgical guide. So once the surgical guide is done, and we're going to see this, the metal cylinders would be inserted or would fit inside these holes. Now, if you're using Blue Sky Bio parts, that's it. The simple press of the button changes the settings. The software automatically puts in the relevant metal cylinder. It automatically sets up the software guide tube information, and again, automatically populates the Blue Sky Bio Direct Cut parts panel. We would then go on to the guide fabrication. The guide fabrication could be done by using the guide panel. The panel is designed to be used from top down. Okay? And many of the settings, once you set it up once for your first digitally designed surgical guide, many of the settings, as we're going to see, don't need to be changed from a case-to-case basis. You could just keep them the way they are. So the first thing you want to do is you want to select the proper model. Okay? Right now we have 2 models in here, and we're 2 STL surfaces in here, and we're going to select the proper model. Okay, that's very important. Otherwise, you're not going to get your desired results. The checkbox here, lock implants and virtual teeth, that's there to make sure that while you're designing the surgical guide, you're not going to accidentally move any implants or virtual teeth during the process. Use automatic brush. The automatic brush, we'll see very clearly the automatic brush. The idea is to remove areas of the surgical guide that are close to the software guide tubes to make sure that the software guide tube is the highest part of the surgical guide so that the handpiece has full clearance to get inside of it. Okay, when you see it, it's going to be perfectly clear. But again, the idea, for example, here the surgical guide would be on top of the tooth a bit, and it might provide or create interference for the handpiece to reach the top of the surgical template. So the automatic brush is going to remove that by whatever's set here. Default is 15 millimeters, and you could leave it like that, or you could change it. The guide quality, you could switch to high or to very high. The higher the guide quality, the longer the processing might take to make for the software to process the surgical guide. Instead of taking 1 minute, it might take 3 minutes, depends on your computer, but it's recommended to go up to high. The difference here is the resolution of the surgical guide that's going to be created. It's going to go for printing. Okay. The high functionality is 0.05 millimeters, and the very high is 0.02 millimeters or 20 microns. In a perfectly ideal situation, the optical scanner is scanning at 20 microns, and the 3D printer is printing at 20 microns, and the software is meeting that accuracy as well. In reality, usually the accuracy or resolution is a bit lower, and you're dealing more with the 0.05 millimeter range, which is fine as well. Okay, so you could select high or very high. You go ahead and select the jaw type, and even though we've rotated this a whole bunch, this really is a maxilla case. And then you could select remove undercuts. Most people do select that option to remove the undercuts, and it's recommended. The guide thickness, you're able to change. By default, it's set to 3 millimeters. The vast majority of surgical guides are made with 3 millimeter thickness. There's no reason to change that unless you're looking to have a particularly thin or particularly thick surgical guide. Now, the settings that we just did now on a case-by-case basis, really the only thing that you need to change is just to confirm that the correct model is being used. Once that's done, then you're just going to jump right into drawing the curve. The point of drawing the curve is you're defining the area that the surgical guide is going to sit on, or you're defining the area that's going to be used to fabricate the surgical guide. So you select the Draw Curve button, and when you want to start drawing the curve, after you've positioned and rotated your model, you hold down the Shift key, and you just run around with your left mouse button while you're holding down the Shift key, and you draw the curve. Now, the initial drawing of the curve could be done pretty quickly, and you're going to have the opportunity to fine-tune the placement of the curve afterwards. So here we have our curve. We came back to our starting point. Once that's done, you go ahead and select Edit Curve. On the curve, there are lots of nodes that show up, and you're able to grab any of them and to fine-tune the placement. So you could go around the curve and adjust it as you wish. The two important points to remember is you want to make sure that the line or the curve doesn't cross itself at any point. And you also want to create a smooth curve with no sharp points or edges. If you don't like your curve and you want to create a new one, then you could just press Clear Curve and redo it and redraw the curve. Once you're happy with your curve, then you go ahead and press Fabricate on Model. It's as simple as that. You draw your curve, you press Fabricate on Model. The software will run for 1, 3, 4 minutes, and then you'll have your surgical guide. In order to save time, I have done it ahead of time. And here is the model with the surgical guide. Let's turn off everything else except the model, except the surgical guide. And we could see here the completed surgical guide. We have the holes which are going to have the metal cylinders inside of it for guided surgery. You could see how it looks from the bottom. And we could see here the automatic brush and the effect that it had. The automatic brush has automatically cut out this part of the surgical template. Purpose being to provide access for the handpiece to be able to reach the top of the surgical guide. It also creates nice little windows where you can make sure that the surgical guide is completely seated as it should be. Okay, so that was our automatic brush functionality. Now we have two other functionalities here to kind of finish off the process. They're not required. But they're useful. The first one is our brush tool. If you wanted to smooth out part of a model or part of a surgical template, then you could, first of all, make sure you're using the correct STL surface, and then you could control the diameter of the brush, you could control the strength, and with your left mouse button while holding down the shift key, you could just go ahead and brush the model and it will smooth it out. Okay, one of the reasons that this might be useful is if you want to put text onto the surgical template. Now, obviously, the brush tool should not be used on the inside of the surgical template because it's going to change the fit and how it's positioned. But it could be used on the outside of the surgical template, especially if you want to add text. You could create a nice flat area there. The text, you could add any text that you want. You could put the patient's name, you could put your name, you could put the lab's name, whatever you want to do. And it's done by typing the text into the box. And the positioning and the size is controlled by manipulating the surgical template or whatever surface you're putting it on. Okay, so you could rotate the surface, you could position it how you want. The more you zoom in on the surface, the smaller the text is going to be. And the more you zoom out, the larger the text is going to be. Once you're happy with the positioning, you can go ahead and press the apply button. Again, make sure you're using the correct surface. And the text is embossed onto the surgical guide or onto the surface, and it will be printed that way. Okay, so the brush tool that we have on the bottom and the label tool are two nice other additional functionalities. Not required. You could do the surgical guide without them, but they're there as well. Let's summarize our process flow and the guide panel. We started at the top. We made sure we're using the correct model. We lock the implants in virtual teeth. We use the automatic brush. Highly recommended. The automatic brush diameter can be set here on the slider. And we bumped up the guide quality to high, or you could bump it up even to very high. We jumped over the scan appliance section because currently we're not making a surgical guide based on the scan appliance. We're going to get to that in just a few minutes. So we've jumped over that. We went to our model settings. We selected the draw type, removed the undercuts. We kept the guide thickness as it is, and we went to drawing the curve. Now, drawing the curve in all situations after your first surgical guide is going to be the first step in the process. Everything that we did now is going to stay the way that it is. You draw the curve. After you draw the curve, you can press edit curve. You could fine tune the placement using the nodes. If you want to clear the curve, you can clear the curve. And then you press Fabricate and Model, and it creates the surgical guide. The brush tool and the label tool are two extra add-ons that you could use if you like. The brush tool could smooth out an area, and the label tool could put text on the area. Now, if you decided to change something about the surgical guide, let's say you're using different drills or you realize you made a mistake and you want to change anything in the implant list, then you could go ahead and do so. The surgical guide that already exists will not, for better or for worse, which I actually think is for better, and it was designed this way, won't update itself automatically. Okay, it already exists and it's not going to change based on changes made after the fact. What you could do is you could just delete your surgical guide and redraw your curve and then make a new one. And even when you're redrawing your curve, you don't need to redraw the curve. You just press edit curve and the previous curve shows up again. You hit Fabricate and Model and you're good to go. So we just discussed the process of making a digitally designed surgical guide based on the Blue Sky Bio parts. Now, if you're not using the Blue Sky Bio parts, that's not a problem either. First thing you need to do is determine which metal cylinder you want to be using. You're going to determine that by the size of the keys or handles or drills are going to be going inside of it. Once you have the metal cylinder information, then you'll go ahead and make the changes to the software guide tube or the manually. So, for example, if we're using our very popular 5.02 internal diameter metal cylinder, and the outer diameter of it is 6.02, then we need to make the holes in the surgical guide to be slightly larger than that. So we're going to make it to be 6.12, which is 1/10 of a millimeter larger. And we'll make the outside diameter to be 8.12, which is 2 millimeters larger. And what the difference between the inner and the outer, it creates our wall thickness. It creates a reinforced area around the metal cylinder that's going to be placed into the surgical templates. Now, we don't need to go ahead and manually do this for every implant. We could press the Copy Tube Settings to All Tubes button, and we could see that the settings were adjusted accordingly. Now, if we take a look at this example and we see how the software guide tubes are overlapping each other, if they're overlapping just on the outside of the software guide tube, you don't need to be concerned because it's just printed material that's going to be part of the surgical templates. The point of concern is if the overlap enters the inner diameter space. Okay? Because in that situation, you won't be able to put the metal cylinder inside of it. There's going to be interference. What to do in that situation is either use a smaller metal cylinder. If you want to separate the implant slightly, then that could be done as well. So to summarize, if you're using the Blue Sky Bio parts, you press the direct cut settings for printed guide. If you're not, you press the button anyway, and then you make the manual adjustments to the software guide tube. You can make the adjustments once and press Copy Tube Settings to All Tubes. Now, the metal cylinder numbers, metal cylinder inner diameter, metal cylinder outer diameter, cannot be changed. And they don't need to be changed because they don't affect in any way the surgical guide. Why are they there? Because we want to show visually, first of all, which the relevant metal cylinder which should be used if you're using the Blue Sky Bio parts. But if you're not and you're putting the numbers in manually for the software guide tube, you don't need to be concerned about the metal cylinder settings. We're actually going to be pulling this out in one of our upcoming versions. We're going to be removing the metal cylinder settings from here. Now that we have the guide panel, the information is presented in the guide panel, and it doesn't need to be shown here as well. And that's that. We're also in our upcoming releases, we're going to be simplifying the process, both processes of the model-based surgical guides and the digitally designed surgical guides. We're going to be streamlining the process even more and simplifying it even more. So that's something that we're working on now. Okay. So we have discussed the process of importing the model. We have discussed the process of making a model with posts for thermoplast or suck down for Blue Sky Bio parts and not Blue Sky Bio parts. And we've discussed the process of digitally designing a surgical guide for Blue Sky Bio parts and not Blue Sky Bio parts. So that takes care of that. Let's discuss, with some of the time remaining, we're going to be discussing how to make a surgical guide based on a scan appliance and where you could have the stuff printed. We're going to jump over to a different case, and we're going to be looking at this case here. We are not going to be discussing now how to import a scan appliance. We assume that you are familiar with that process, or else you could become familiar with the process at a different time. We're starting from the point where we have the scan appliance imported, we have the treatment plan done, and now we're ready to make scan appliance. If you're using Blue Sky Bio parts or not using Blue Sky Bio parts, the discussion is the same as before. If you're using the Blue Sky Bio parts, you don't need to make changes. And if you're not using Blue Sky Bio parts, then you should put the numbers in manually. And that really summarizes whether you're using the model with posts, whether you're using digitally designed, or whether you're using the scan appliance technique. If you're using the Blue Sky Bio parts, things are set up because we have all that information. And if you're not, then just put the information in manually. So now we're at the point where that's done. We have our imported scan appliance. We have the treatment plan completed. And the guide fabrication process couldn't get any easier. We're back to our guide panel, but all we need to do is to make sure we're using the correct scan appliance and then press the button Fabricate on Scan. That's it. Once that's done, if you want to use the brush tool to brush or put text on, you could go ahead and do that as well. So how's it going to look after we press the Fabricate and Scan button? And to save time, I have pre-done it. And this is our surgical guide. Okay, another recent update that we did is we've incorporated the automatic brush functionality to work on scan appliances as well. So here, for example, it would be recommended to use that to get rid of the teeth that are showing on the scan appliance for full access. Okay, that's the automatic brush that we have here. And the brush tool could be used the same way as we mentioned earlier. That could also be used to reduce the teeth. And we've designed it that when you're using the brush tool, it's not going to brush the cylinders. Okay, so you could freely, first make sure you're using the correct surface. You could freely brush the areas around the software guide tubes, and you don't need to be concerned that you're going to be changing the shape of the software guide tube or changing the shape of the hole that's going to be holding the metal cylinder. Okay, so that's an extra benefit that we've built in here as well. So to summarize the process of fabricating a surgical guide based on a scan appliance, basically all you're doing is you're using the correct model, you're pressing fabricate on scan, and you're done. It's not very different than drawing the curve either, where instead of pressing fabricate on scan, you draw the curve and then you're done. Both situations, you can use the brush tool or the label tool if you like to make your surgical guide. Okay, I'm gonna keep on going. If there are questions, then enter them into the QA box, and in a few minutes I'll address them. Okay, now these techniques allow for in-house guide fabrication, whether you're a clinician, whether you're a lab, they could be used. Now both of the techniques and both of the option of either going through a lab or making your own surgical guides are valuable and are needed and serve different clienteles. There are dentists that want to do it themselves. Maybe they're more tech-oriented. Maybe they enjoy being more involved in the process, and they can make their own surgical guides, and it could save them a bit of money. Obviously, they need to go through the process of the learning curve that we're discussing now. And there's also the ability to order the surgical guide completely through a certified lab. And really, that's the direction that the vast majority of dentists are going in and are taking advantage of. And both the possibilities exist. Now, what happens if you want to fabricate the surgical guides, just like we're discussing now, but you don't have your own 3D printer? So we have listed on the website 2 different printing centers that could go ahead and print the items out. You could see the packages are in the $35 range. Exactly what it includes or doesn't include. Some of them actually include scanning the model as well. If you don't have an intraoral scanner, if your local lab doesn't want to do that, then the $35 package should include scanning the model, printing out the model with posts or the surgical guide, and they'll include printing the drill stops as well. The $50 package is similar. It includes the STL export. They'll do the export for you. And that's also a good option. The contact information and links to the websites could be found here. Now, just a word about the STL exports. So the software for treatment planning purposes is completely free to use. As you probably know, you could install on as many computers as you like. You could get as many licenses as you like. There's no fee involved. The only fee involved is if you're exporting the data to STL for surgical guide fabrication. You could see the packages and the price ranges go from around $20 a case to around $11 a case, depending on this package that you're buying. And the way that it works is that we'll send you a license that you put into your software that activates that number of exports, and you go ahead and you use them whenever you're doing a case export. The count is per case and not per export. The distinction being if you're doing multiple exports from the same case, either because you made changes or you want to, let's say, export the anatomy as well. So you could do multiple exports from the same case, and it's only counted once. So that's a word regarding the exports. Now the page that we're looking at now, or let's back up a little bit to this page. This page is really the home page for anything related to the software guided surgery. How did we get here? You can either type in blueskyplan.com into your browser and it'll automatically come up, or you can go to the Blue Sky Bio website and then click on the software tab, and it brings you to the page. Now the page has a lot of useful information. You could download the software. It has information regarding our guide tubes, has information regarding our direct cut drilling solution, which I'll mention in just a minute. And then what we're really interested in is in-house guide fabrication. This is the page that describes everything about the two different techniques for digitally designed surgical guides or the printed model surgical guides. Both of these are clickable, and you'll get to more information regarding that. The information regarding the printing centers and some frequently asked questions appear on this page as well. The direct cut guided surgical system is an option for a guided surgical kit. I mentioned at the very beginning that the two financial barriers that used to exist to get started with guided surgery, one being buying the software and the other one buying the guided surgical kit, has been removed. Okay, the software is free for the dentist that wants to start getting involved with treatment planning, and the direct cut guided surgical system provides the solution for the guided surgical kit. The drill is engineered to be a direct cut drill, meaning that you don't go through the process of winding an osteotomy. You just use the single drill for the relevant implants. This removes the need to be using any keys or handles during the surgery. It simplifies the surgery. It streamlines the process. The dentist uses the one drill that they need for the case, or in some situations it could be two if you're using multiple sizes of implants. You're using the one drill for the case, and that's it. Okay, the drill goes through the middle cylinder in the surgical guide. You get the angulation and the placement, and you're good to go. Now, how do you control the height? The height is controlled by using a printed drill stop. For every implant, there's a corresponding printed drill stop. The relevant drill stop is shown in the parts panel. It's an STL file that can be downloaded at no cost. It can be printed wherever the surgical guide is being printed or the model post is being printed. You could have them print the drill stop as well. The drill stop here is green. You could see how it goes over the drill, and it stops the drill at the correct height. Okay, so that's the built-in drill stop. The drill stops could be reused or they could be tossed. They're usually sold for a couple of bucks. The drills are designed to be reused. They cost us $76 as well, but the price, is very reasonable, and it prevents a situation where a dentist needs to go and spend a significant amount of money in a guided surgical kit. It's really what this is doing, what the direct cut drills are doing, is providing a guided surgical solution in a single drill. So that's just a word regarding the direct cut drills. Okay, let's take a look at some of these questions. The presentation is being recorded, and shortly after it's done, it will be live on YouTube. So if you missed parts of it, or if you want to watch it again, or if you want to share it, then you could find it on YouTube. You can also find it on our website. Speaking of which, information regarding on how to use the software, you can see at video tutorial section right here. It's broken down by feature and functionality. Each video is a couple minutes long, and that's a good resource for you or for dentists to learn how to use the basic functionality of the software, which we haven't discussed today. The information and tutorials regarding guide fabrication is found in the in-house guide fabrication section. We also have past recording webinars that cover the topic of basic Blue Sky Plan functionality, advanced functionality, guide fabrication. You can see there's a list here as well. This is where the recorded webinar is going to appear, and you can see some past ones on similar topics or different topics. So that's available via the recorded webinar, and we have our upcoming ones that can be found in the educational webinar section. we constantly come out with new upgrades and builds to the software. The software prompts you to automatically upgrade. It could be in differences of sometimes even weeks or months. Some of the newer functionality that we're working on now, including simplifying some of the functionality for guide fabrication, is expected to come out probably beginning of 2015. We've recently introduced an automatic intelligent panoramic curve and some other functionality, but that's really been great. Now, when you load the case into the software, the panoramic curve is drawn for you correctly automatically. So that's been a recent release to the software. And the bone definition that we mentioned earlier for bone support surgical guides is new. We have tooth extraction functionality that's new. We have other new functionality regarding virtual teeth and placement of virtual teeth that's new. We're constantly working on software. We welcome suggestions and recommendations, and we do our best to accommodate. Regarding conversions from CEREC, I was told that you could actually speak to them, and for a fee, they could convert it to STL. I also know that if you're able to export to CDT, then there were or are functionalities that could convert it to STL. Okay. If there are follow-up questions, then please do not hesitate to contact me. My details, email and phone, are right over here. And you can also contact the main line at Blue Sky Bio. They'll give you my details. My phone number appears in many situations when you download the software, when you get your license. So you could call me, you could email me for any follow-up questions or follow-up training that you would like to receive. Okay, that pretty much wraps up today's presentation. Please do not forget to enter your details into the webinar attendance form in order to receive the CE credit. Links to the form can be found under the viewing video screen that you're watching now, and it was also sent out earlier today in the email regarding the viewing links. I like to thank everybody for attending, and don't hesitate to contact me with additional questions. Enjoy the rest of your day. Thank you very much. Bye-bye.